India and Singapore, a highly respected strategic consultant in IT across APAC countries. Mr. Deepak brings with him impressive and wide-ranging experience in the field of information technology with a strong focus on AI-driven future technologies and their real-world applications. Over the years, he has played a pivotal role in strategic consulting technology adoption and digital transformation initiatives for organizations across the Asian Pacific region. Beyond his professional achievements, Mr. Deepak has consistently demonstrated a deep passion for mentoring and guiding young minds. He strongly believes in empowering the next generation of professionals and entrepreneurs by combining strategic leaderships with innovation in emerging technologies. His mentorship and vision have had a lasting impact on both professional communities and education ecosystems. With his unique ability to bridge technology, strategy, and innovation, Mr. Deepak Gupta continues to aspire individuals, startups, and enterprises to embark the opportunities of the AI era. Now I request Mr. Deepti Gupta sir to take over the session. Thank you.
Hello.
Sir, you are audible, sir.
Okay. Should I start now or somebody else is to
Yes, sir. You
join?
can you can start, sir.
Warm welcome to everyone. Good evening. And probably I'll share my screen in the beginning itself because it's a kind of presentation where we have to go through a lot. This seminar which I'm presenting is more towards future of the technologies, primarily into IT. And let me share my presentation and let me know if any one of you, if you can see the slide share. If the slide screen is visible, do let me know. Any one of you?
Yes, sir. It's visible.
All right. Is this visible properly?
But sir, there is some sort of line, a box-like structure
I
displayed
will,
on your.
because that's a zoom setting, I will keep it on side.
Yeah. Okay.
All right. Right. You need to give me a half a minute because the double screen sharing I have enabled. And I will make it a duplicate so that things are seen everywhere properly. All right. Thank you. Thank you for having patience. Yeah. Okay. Thank you, everyone, for joining on that to an evening. Many places it is a holiday already, and that to a Teachers' Day today. Thank you to all of the teachers who have made our life impossible to possible and possible to successful. 1 second. The lines would have been creating problem for you. The line might be going on the top now. Hope that is okay for every one of you. That's a zoom setting. So welcome, working on the future of
But
systems.
your screen is not visible, sir.
My screen is not visible,
Yes, sir.
right?
Just we are
I'll
able to see the mouse cursor.
I'll reshare and see if it is.
Yes, sir.
Is that you are able to see my presentation screen? No?
Not yet, sir. I
Okay.
think it's yet loading.
Let me know if it is not. I'll do a change.
Yes, sir. It's visible. Okay. So the top box, I mean, like on top of your name, we are able to look at some box like things.
That's a zoom setting actually. So the screen with emblem of India and Deepak Gupta working future, that slides is seen.
No, sir.
Uh,
Again, the screen has disappeared.
okay, that's a setting with a Zoom. Can somebody take up the host of the meeting, because somebody have made me the host, and unfortunately, the appointment of everyone's is welcoming popping to me. That setting has to be corrected. Can somebody do that?
Yeah, just a minute, sir. I'll remove
Yeah.
you as the co-host and I'll enable the
Yes.
participant screen sharing and everything.
Yes. That
Yeah,
will be
give me a
better.
second.
Thank you.
Sir, I had removed you as the co-host, sir. Kindly check
Perfect.
one.
Just I'll share it.
Yes, sir.
You have to.
I'll enable the permissions for the meet, sir.
Yes. Thank you.
Yeah, now it's fine, I think so, sir. You can
Right.
share the screen as well.
All right. Are you able to see?
No, sir.
All right. No, I haven't shared yet. I'm really sorry. Is it seen now?
Uh, Still loading, sir.
Or is it?
Again, a blank screen, sir.
Pardon me. Give me a second. This should not happen. Are you able to see now?
No, sir.
No.
No, sir.
1 second. Screen sharing I have enabled. I should be able to see.
I think it's better to share the whole screen, sir.
I have shared the whole screen. Right now, you're not able to
Yeah,
see anything.
now it's visible, sir.
ఇది
All
That
జూమ్
right.
with your
మీటింగ్
name and
పెట్టగానే
your
ఆటోమేటిక్ గా సైలెంట్ లోకి వెళ్ళిపోతుంది బంగారు.
Okay. Now it is seen, no?
ఇది లేనప్పుడు నా దాంట్లో
yes, sir.
లాగిన్
Yes,
అవుతా
sir.
బంగారు.
All right. Maybe others can mute themselves if required.
I'll do it, sir.
All right. I'll straight go
Yeah.
with the evolution, whatever has happened into the computing. I'll just reframe my requirement here is to help you to understand how the future of the technologies will come up. Though it is a very dry topic, but I request humbly to everyone to give me your 1 hour. My name is Deepak, call it Deepak Gupta, and I primarily work on future of the systems. I do heavily research on finding out how the systems of the future will shape, and we need to give the best to understand here opportunities, options, and how this can help us in our career and obviously for our nation and our society. Some of the things are very simple. I have not put many of the things new for you. Any point of time, if you find that the screen has a problem, please, any one of us, let me know. I'll not be able to know. So a lot of things which I'm putting here is known to you already, but the orientation and presentation would be different. Evolution of computing, mainframe and PCs, all of you have an idea how that goes about, how the mainframe, how the PCs, how the internet, how the cloud. Very honestly, the current generation of you who are in colleges or researchers would have started finger touching AI, suspiciously knowing a little bit of quantum and metaverse. Honestly, I'll not be taking too much time on explaining what they are, except the quantum and metaverse. In your understanding, it could be a future of technology, but in my understanding, it is the future of business. Quantum in one line will help you to make your work done faster. But if you are into applications of computer, you will not be able to see the magic of quantum because that will be happening beneath your keyboard. Obviously, the quantum is more towards a number of options a chip can take in a given shortest span of time. But when it comes to metaverse, what you see, augmented reality, virtual reality, the words, that will play. So a lot of new entertainment divisions will come up. This is already started coming, which means like when TV came, radio slowly become obsolete, means the vision has taken the audio. Likewise, the metaverse will create a lot of new opportunity, not only into extrapolating what research, science, medical science can do. It will also bring a lot of new businesses in life. Metaverse more talks about how you make new kind of augmented visions. How do you see the things better? It's near to your AR and VR. Let's see. Obviously, advanced computing career backbone now, AI everywhere. If you see in my slide, I have limited myself to use a lot of AI purposefully because using AI properly required to use it least and relevancy should be taken care of. You have heard .NET, .NET 3.0. How about hearing 4 and 5? 3.0 is more towards embedding your securities on your internet, how you do it better, and how you make things faster. But 4 and 5 will be more towards giving the role blending with IoT and other things together so that we make better in future. Well, AI everywhere is not about you have AI being accessible to you everywhere. It's more towards the processing done by AI will be very heavy. I need to let every one of us know when I say AI everywhere, it is not the chat GPT everywhere. Meaning is when some process is happening, lot of computing will automatically happen using the power of AI. Any example? Let's say you have got some data from an API or some application read handily to you. Before you could even process and analyze, the first screen will be AI who will take care how it is going to be useful, how you are going to use it in further. So it's like a first line of thinking and everything will be AI. Another example, let's say a medical report for a person has come up. Maybe in a future, even before the report goes to a person, it will double check from the person's perspective, from the data available for the person, that should he be called immediately? Should he be updated somewhere else? AI everywhere. Third example will be if you are earning and if you want to plan your investment and earning. Well, on the time when your salary lands, if you have given the access permissions, the bank bots will help you to set up your investment and saving well before it displays you the next set of your things in life. So it's more towards everyone's personal thinking brain. God forbid me, if it is misused, it will be more of a danger because we might think of stop thinking in general. My suggestion would be give your time more into understanding the exposure of AI application, not just the tools. Of course, how the AI is evolving, the parts of AI, machine learning, data science, and all that, you would have hearing it polluted every day. But try to understand how the AI is participating in every challenge of your system, your application, your daily role would help you. And to understand it, even nowadays, to make smarter chip, AI itself is now being used to write the better blueprint of circuit theories and all that. role. This is I am opening to you all that to think every slide I'll try to give you one question in your mind. What role you think you fit well in this case, where AI will be everywhere? Industry better internet will come. When I say internet is not the speed of the internet, opportunities and the features an internet can provide you better. Just think of it before I go for the next slide. I just have one question. Is this going to be just my presentation or somebody at the end can have a question and answer sessions also? Just I need to know that. I'm breaking. Vinla, I'm breaking. Hello, can somebody just let me know that at the end, is there going to be some question sessions or just my presentation?
Yes, sir. Participants are open to ask questions.
Sorry, I could not hear you.
Participants are open to ask questions.
Okay, so what I'll do is I'll break up my session into 2 parts, probably 3 parts. So every 20 minutes, I'll open for 5 minutes for participant to ask me the question. We'll see that audio is helping me, otherwise. Okay. Am I audible? Because I was muted by somebody by mistake. Am I audible, no?
Yes, sir. Audible.
All right. So after 15 minutes from here, I will have a small 5-minute break, not a break, a question session. Somebody can write in a chat. I'll try to answer. If some of you want to, open an audio and speak, I don't know how that relevant is. May the host can decide that. Otherwise, the chat window, I can read the question and try to answer after 15 minutes. And then the remaining slides, I will continue at the end again. I'll give some time for question answer sessions. All right. Cloud has been most misused term in last 10 years. Unfortunately, cloud was made only for centralized data centers, not for applications. But with the ever-evolving IoT, edge devices, the cloud sector has been more in demand and expectation from cloud has gone higher. I'm very sure in future you will hear the stories like, let's say you have made an IoT device where nothing is there sitting on your device, your data, your memory, probably just leaving the RAM and everything will be there on the cloud. But I have to give you one small update here. When we say cloud, lot of companies now have stopped future planning for cloud for next 10 years because the energy power uses by the cloud data centers is increasing year by year, and the bigger champion have started thinking of setting their data center of cloud into the countries where the electricity is cheap, like Bhutan. So that is another opportunity in the future. Like a lot of countries where digital media was not there, electricity was only available. So they will welcome a lot of companies to open their data center for cloud. Another thing people would be talking a lot in the coming terms are serverless and multi-cloud. Well, serverless is known to many of you. It's not a new thing. When I say serverless, it's an extension of your API application where most of your data and the logic is sitting into some other server. You will write your applications, load into the cloud. Nothing is there sitting into any of your devices, and the user directly connecting to the server. That's the real meaning of serverless. Multi-cloud, I don't want to pinpoint like a classroom. I think it is very known to all of you, where if you're a bigger company, you might think of having the clouds more than one, maybe multiple vendors or multiple cloud devices you will be using. Or you can have something in your local called proprietary, like on your, let's say at the college, there is a local data center that's called proprietary. You can mix it with cloud. Where do I see an opportunity in this all? Number one, cloud center itself, a lot of opportunities will come in future. If any one of you have interest in IoT, my one humble suggestion is interact with people who are also having some knowledge of electronics. I have seen in last couple of weeks when I go for some interactions that people try to understand the IoT devices without understanding the chip, how it works in the background. IoT requires heavy understanding of the chip, microcontrollers and all that. So it's not just only application, it's not that only coding and all that. However, to do any of the good business use case, or if you want to become an entrepreneur in future, it's not that everyone should become, but if you want to become, IoT is one of the good starting point for doing any entrepreneurship. 5G is obviously in my seat, but is now old. It means it has now already come 6G and 7G. What it is going to do? 6G is all about speed and 7G is going to be all about multitasking. Imagine a situation where you have a building, you have a Wi-Fi on the last floor, top floor and bottom floor, because the building is surrounded by many other buildings. There is no internet. So 6G and 7G will have a capacity to create its own better strength of the internet using the future of the technology so that internet will be faster. So why the drones are still not doing more and more? It's because 6G and 7G is still not in place. Sooner, when 6G will come, you will see drone is playing role into commercialization of a lot of shipment movement, at least, if not the human movement.
Yeah.
Lot of future movement will be done of the goods using that. Can somebody mute? One of the gentlemen has got unmute by mistake. This is very talked about artificial intelligence and machine learning. I will request you during the question session when I have that 5 first minutes to at least ask something related to this, because in the stack of one cookies or a biscuit box, this is the immediate one going to help you to get starting of your career. If you are into any of application development, if you are into any of chip development, please understand AI and ML are completely two different things. ML is definitely a backbone, but it is only towards analytical part of AI. You might not be able to tap the ML for some of the reasons like heavy math and whatever. But the AI per se, you can be able to do, and everyone will be able to understand and utilize in their business. Understand like this, if you're an engineer and mathematician, you might be focused more onto ML. But if you're a businessman, you just don't need to know how the ML models are going to work. You need the input and output of particular thing. So all the tools which are made these days are not directly interacting with ML. They'll be more towards artificial intelligence, third-party tools are done. I have to tell a lot of participant might think that AI is all about ChatGPT. No, gentlemen. ChatGPT is only the NLP part of AI, not even stochastic or any kind of predictions model or anything. It's just NLP, not even machine learning. It works on transformers. All right. The very fancy word AI brain. It's a term coined quite recently that when I say AI brain, it's not going to replace the brain in human with the AI. It's all about if you want to have a bigger processing, some applications are running, you want to take some decisions. So mixing your ChatGPT, mixing your neural networks, you might be able to take some bigger decisions, complex decisions. Front runner of this kind of system would be healthcare and then finance and education, because in healthcare, you just cannot automate the decision to be done during the surgery or during the course of process of medication. You have a very complex if and but conditions, how much to give them a dose, how much to surgery go for, take the immediate decisions. Well, if it just be successful in that, which is very totally, I'm telling you, in the marketing, they are telling that it's successful. No, it is not. The front runner is Google. They are working using augmented reality, virtual reality with AI to do a surgery. And how to do it? The person will be sitting on 100 times bigger brain scale, let's say, and he do the surgery over there. The small device robots will actually do the surgery, which is actually been tested, but the success rate was not that good. But the demanding is high and they are tapping it. Why they were not able to do is the computing was faster, so they needed the quantum chip. So once the quantum chip is in market, you will see a lot of surgeries will happen remotely, doing the surgery on a different, maybe a 10 times bigger heart, and the actual surgery will happen somewhere else remotely. Is it going to happen in a near future? I don't think so, but it is definitely going to happen. You might wonder how many different kind of engineering career it will evolve for. A lot. Wherever you think the challenges are, they all will be the future of your career. I hear not saying that all those careers will land to our country, but most of that would definitely land. Well, if somebody still have the enthusiasm towards this into entrepreneurship, for them, I'll suggest keep looking towards what Google is right now doing. I'm not advertising anyone here, but they are the only one doing into that right now. And very soon, Meta would be trying on that. By the way, Government of India is also working in that sector with the launch of new chips, indigenous chips. Finance, it will be vulnerably used heavily in terms of people doing trading and investing and making more money, faster money. Education, I'm eager to see that happen, where you will have a virtual teachers. But I have to tell you here, not for the sympathy, but the reality, how hard we have tried using data. I was personally involved in one of those situations to eradicate a practically human teacher with a robotic kind of teacher. It was almost impossible because when the student teacher interaction was happening, the device was unable to read the sympathy and empathy of the student, the level of the fear or emotion. It was not able to read. By the way, that is today. It might happen tomorrow that so-called the teacher of AI comes. AI as a teacher may come, but in the near future, mathematically not possible. Who will help in this? The technology which is called generative AI, will it help in this? No. Lot of people have started thinking that if we could somehow tap generative AI, it can replace us teacher or a tutor or a mentor. No, the problem is the teacher, if you realize and if you have ever taught, you do not give an answer based on what the question is being asked. You always think what the intent behind the question, and that intent thing comes from the prejudice mind, which generative AI is still failing to do. Can be mute. I guess somebody is there on off. Okay, thank you. Will AI be able to help us in future in terms of our job? Well, very sure, I'll tell you. Anyone who even know Python, very basic Python, and only know Python, I'm damn sure they will have hell of the opportunities in future. That doesn't mean I'm branding Python. I'm just telling it's any coding language also if you know well. So I had one heated discussion that is that the era of knowing language coding is gone. No, the more it is now. If you know the language coding language better, opportunity will be more full. So that's about AI part. Data-driven computing. Maybe somebody later can let me know what is called data lake, or maybe somebody can just quickly type if anybody know that typing is enabled for participant in the chat window. Can they? Okay. Nobody. So chat window will be seen, right? To the participants. Okay. Can somebody reply to that? The chat window is seen to participants. Okay, nobody is there. All right. If in case somebody is writing, do anybody have an idea about data lake? Just I'm asking if somebody already knows, any of the participant. Right. No, somebody understood. Anybody else? I'll give you one simple example. When you have database and humongous number of databases where you want to crisscross between different kind of data, different databases, different tables, a next version of analytical data where heavy data you want to dip into, take some data from this, take some data from that, blend it and give some important things. That base is called data lake. So basically a lot of databases where tables and everything you can share. Okay, somebody just drew. All right. Here I have made a arrow, data lake, real-time analytics and insight. I'll explain. You have a table, you have some Excel sheets, you are putting it into your databases. Next level will be having that data accessible across table, across database, across server, across one laptop to other laptop. That makes data lake. When you are able to do it fast as per my need and my AI is able to cross through many databases, that becomes real-time analytics. And when you are able to work across multiple databases, multiple systems picking up the data, you'll be able to analyze data better. So this is a completely different set of future computing. It's not AI, that how the data will play the role in terms of accessing data, processing of data, presenting the data, making dashboard. So as of now, you can focus when you make a dashboard, maybe an Excel sheet data, maybe a table data, maybe a database data. But we are talking about across globe, multiple places accessible data. You should be able to pick and make. If that is the fundamental thing, big data is the history. Data mesh is present where you pinpoint from which points like a grid, you will pick the data. But the processing again, you need the quantum. In the recent future, things which will immediately come to you in terms of new set of career opportunities, data lake is going to be the front runner. Like when a lot of .com boom was happening, it's not that application training or application coding job was more. It was a database analyst and administrators career opportunity was more. Likewise, now also, everything will again bounce back to heavy data processing. So if you are good at these things, so at least give some your time on understanding basics. What is the data lake? Don't immediately jump on doing some certification on these things. Just understand if it is relevant, then talk to your faculty, teachers, trainers, or your mentors. Maybe probably they will help you to understand. Or if there is somebody who is done PhD or something in advanced level into deep data sciences, they'll be able to get you some insight. I would humbly not suggest somebody, an entrepreneur, to land into this because the costing involved immediately. But yes, to get a good, handsome, decent salary and all could be a good thing. Data vault is another thing you have to look for. This is a talk of a town always, cyber security and zero trust. Possible for anyone just to write why the blockchain is there on this sheet? Anybody have an idea why I have put blockchain here? If it is cyber security, any chat? No? Okay. Okay, somebody has written data lake is central repository. Very good. Can somebody give me a hint about why cybersecurity and blockchains are together required? Okay. I don't hear anything. All right. With 118 participants, looks like everybody is finding his evening of holiday. No problem. Blockchain was actually being evolved with an idea that if I do alter anything with my data, any alteration with my data, whoever is participating in that data, everyone will be notified. And until unless everybody approves, you cannot change the data. Okay, somebody wrote me to me. Secure transactions, sir. Okay, thank you. Sudhir has written it. Sudhir Kunneru. So I was trying to say the technology, how it works, to call journaling, which is a common terms in commerce, where you do anything, you write like a sequence. Think about a diary where you have written something on a page number 10. You want to alter it. You want to tear the page. If I tear the page, people will get to know that it's been torn because the page number is there. Blockchain works on that. Why cybersecurity and blockchain coming together? Take an example. In Indian judiciary system, there are 4 cases running against one person, and he is saying in one case that I do not have money. I'm giving very vague example. Another place he is filing his income tax with 8 lakh rupees of earning in a year. Right now, the situation was not integrating judiciary system, though it is now being done slowly and faster. We were unable to know what data somebody is producing at one place and what the other place. And if you try to alter at one place, the alteration will reflect the other place also. So integrating the data securely goes to blockchain. Till today, the blockchain has not been actually used properly. I think in the recent time without this, we cannot think of a better cybersecurity. Example, let's say you are doing some transactions and cyber hack is happening. Without blockchain, it is possible. With blockchain, it won't happen. For your transaction, maybe it would require some other person also to approve, which looks funny for you, but something like that. Plus, if the transaction has happened, the trail will get to know the person who has taken your money, where it is landing to, and from there where it is going. All will be trailed. That's how the blockchain will help you. Yes, that's a defense mechanism of future, but that is immediate to happen. All that cyber threat is suggesting towards that. One more wrong assumption is to implement blockchain is required lot of computing power. No, gentlemen. Implementing blockchain doesn't require huge amount of power. There is a technology called peer-to-peer data handling. That is the reason you need a lot, because centrally you are not keeping the data. You are keeping the data across the laptops or the devices. That's the reason the blockchain architecture takes a lot of energy and power. If you make a centralized way for everything to look before it passes to the next node, you will not. This become very technical for you. But in short, blockchain will be a future thing in India. If you ask me, at least in next 5 years, I would see some tractions happening towards blockchain rules by the government of India itself. Not when I say blockchain like cryptocurrency and all, for the actual document preserving properly. You will see cybersecurity and trust. Right. Any idea? Qubit? Anyone? Anybody have any idea about qubit? Quantum bit. It would be not a good day today to explain you what is quantum bit, but just understand when you have a bits, byte and bits. In a quantum, the numbers are very higher. In simple term, there is a boy who can only speak yes or no. Now the boy is able to speak a full song. A small boy, if you ask him, have you had your lunch or a dinner? He was actually telling, yes, I had. Now he is able to tell the whole story about it. I'm not giving you the technology behind qubit. I'm just trying to say how the end of the these things would help, right? Why quantum will be required, and the question, is it going to be helpful for you? Well, if you are working into this industry, which I have after research written, drug finance and logistic, you will find yourself being directly getting a lot of opportunity in terms of quantum applications engineering. Drug discoveries, we have seen this during the COVID using our, not 100% quantum computing was used, but faster processing. The processing of bacteria into different DNA and all that takes a lot of time. So we could reduce from 1/10 and then 100 times faster we could do it. I don't want today's discussion, to look like a chit-chat discussion. Just to give a brief, quicker and faster, long processing data happens in drug discovery, finance. When I say finance, it's not about finance. It will help you more towards your planning of your finance. Even today, there's not much of the brain being used in finance planning. So that's the reason it will help. Logistic, when I say it's a transportation and how do you let the things reach to somebody faster. For that reason, we say logistic. I think I want to give 5-minute time now before I go for the next slides. I have many slides, but still, I want to hear from people before I, jump into the next slides. If you have somebody have any questions, they can ask me. Does anybody have any questions? If somebody have anything to ask, please ask me. You can write in the chat, or if you want, you can you can unmute. Let's say if it is, maybe we can give 2-minute unmute authority to people. Let's say if they are able to not create noise. If they create noise, then we will stop it. Who is speaking and I'm unable to hear? It's better we mute people and let them write in the chat, because I'm unable to hear who is speaking. Yeah. So Mr. Sudhir has asked how quantum computing is useful in detecting fake medicines. I'll be able to give you a generic advice here, not the long term. Number one, quantum computing will directly not detect the fake medicines. When you make a medicine, it goes through a long testing process on non-living, then living, rats and all, and then the bigger animals, and then it comes to human. If it is for human, the medicine. If it is for animals, that way. So the DNA pattern for the medicine, how it works, get tested. There it helps. I guess your question is more towards fake medicine means alter medicine, or it is more towards the composition salt is wrong, or is it a proxy medicine being sold in industry? Sudhir, can you write? Okay. Proxy medicine, then it is more towards not medicine science. It's one logistic problem. It is very surprising that the batch numbers and all today are well maintained. So not quantum, but blockchain will help you in that. If the batch numbers are well placed on everything which is placed, like a journal number, and when you are buying medicine, if you get to know what number has been altered, who is eating. Right now, the batch number, in one batch, you can have plenty of medicines. So if the batch number is reduced to per strip, like a barcode, and then make it trackable, like a currency note, then proxy medicine will be almost impossible. I do not see that 100% eradication, but if you make each strip of a medicine and stop selling less than a strip for whatever reason, making with barcode, token code, token number, tokenization of each strip, basically, I'm saying. Is it possible? Future may be possible. All right. Any other questions till now? Otherwise, I'll have to move on. Somebody just scribbled on the screen, maybe if it can be removed. I think administrator, can you just delete this? Somebody just did it by mistake. I'll try to delete it. All right. Okay. No problem. Somebody did by mistake. No problem. I'll go for the next slide. Just I need to be sure that it is seen. Just any one of you. Is it visible? Right. IoT, smart network. As I was earlier saying, 6, 5, and 6. Thank you. As I was saying earlier, 5G, 6G. 6G is already, I have to inform you, with a limited authority I have. I am being part of it, little bit to it. There's a company called XCOM, have worked heavily on this in US. And surprisingly, XCOM is in India also. So they have worked on 6G technology heavily. And the biggest user is right now Walmart and Facebook. Walmart, they have the warehouses huge and big, and column-like things will be kept. So to pick up a product from particular location, they send a Wi-Fi signal to a robotic arm and it picks it. But the columns were kept so close by, it was very difficult for the Wi-Fi signal to reach between these two columns. So there they have implemented 6G technology in a way, which is a proprietary technology right now. But the one line is to be understandable is the strength is much higher. And if anybody is saying, oh, the other countries have 6G, no, they don't have a technology 6G. They have strengthened the bandwidth of 5G. Actual 6G is not into the custom used. It's not for the customers use as of now. It's a business to business use right now. What will be the benefit, as I was earlier saying? If you come right now, the 5G towers, the height, so 6G tower height has to be little lower and 7G tower will be much higher. So a lot of new infrastructure work will come, lot of job roles will come. Every country this will happen with 7G. There are some technology evolution is happening where you don't need to have the tower, the cable, anything. But that's in the recent future to understand how the technology changes too. Of course, low latency will happen. There is a new keyword has come, Industry 4.0. Anybody have any idea then what was Industry 1, 2, and 3? Anybody? Okay. Industrialization of 1700 onward till 2000 is all you can say Industry 0. With IT is 1, 2. With digital transformation and AI, it is 3. Industry 4 is just a futuristic imagination. It's like saying beyond AI, what will happen? Will that people will be sitting at home, getting things all done? Will the drone will ship your products from the store to you? Will that cooking will be stopped completely at home? Just in time, what you want to eat will come to. So all these things, though it looks funny, but 10 years back, instant delivery or Swiggy, Zomato and all that was also looks funny, but now it is the current reality. So that is there. Is that anything to do with between IoT and 5G or 6G? Anybody have any answer to me? Is there any challenge in IoT which 6G or 7G will help in future and which will get you a lot of good roles in industry? See, all IoT devices will work only with the internet. The smaller IoT devices would go, and the more IoT devices will come. You need more and more bandwidth. You might not be seeing right now a lot of IoT being used. Any guess why? Because almost all devices right now you see is human intervention having more, like mobile, TV. IoT wants you to have least interaction. Maybe there will be, let's say some drone is sitting, just taking a picture. You want to order, you say by voice command to your mobile, I want to order. And with a couple of 10-15 questions on your devices or mobile, you order it. Now the order will kick up another IoT signal to the drone sitting somewhere. This looks like a movie fancy thing, but is very soon going to happen. Then that drone will ask for the command from the drone pilot. The pilot will run the drone, not me or you, or maybe an automated or drone, which is right now not going to happen as per the Indian law of aviation, but future will happen. Then that IoT device between the drone and the nearest store where it is available. So your scooty wala who is bringing you the stuff from Swiggy or Zomato or anyone will become the drone. But who will talk to it? The technology will use between the devices will talk to each other. Another best example which is immediately happening is called home automation. Take some time to understand how the IoT is helping home automation. So that's there. All right. This one would be for sure happening in future, whatever happens, because this is going to evolve our movie industry heavily, TV industry heavily, all short of display industry heavily. I need not to tell what is VR and AR. I need to tell how it is going to help you in future in terms of your career. If you really want to get into VR business or AR business, not business, a career, you don't need to learn more of AI part. You need to learn better about, how do I give an analogy? If you know what is user experience UX versus web development. So in web development, you talk about how the code is written in HTML and where it is kept. But in UX experience, you think from the user perspective, what he will click, where he will click and all that. Likewise, inside of AR and VR, there are two parts, whether you work on the technology of augmented reality, virtual reality, or you go ahead and make the products out of it. So let's say a hologram film where it looks in the picture like it is next to you standing, where there'll be more opportunity, different kind of tools and technology will come. You try to use it into, of course, teaching and education sector is the first one looking for it to help, but it is not going to replace the knowledge required. It's like a bot standing and acting like a character. So it's a character's replacement, actor's replacement when it comes to AR or VR. One more thing, right now you need the spectacles to be used for AR or VR. Goggles, VR goggles it are called, but in future you just don't need it. With the blend of hologram and VR technology, you don't need to wear something on top of your eye to see things. Maybe in the future you will see the television industry is completely going. This is, even I do agree that it might happen. When? Well, that depends on how soon the quantum computing and IoT works together. But it is definitely going to happen, and this is going to the biggest industry after television and all. Yeah, somebody wants to ask, can ask. I don't mind. From now on, any slide, somebody can ask a question on chat or anywhere else. Okay. Blockchain and Web3. Nothing is new in this. Well, you might be, some of you who are joined late be thinking that what it is going. I'm trying to give you all the future technologies evolving out of the current technologies, how it will help you in your career. This is not very new. This was known long back, and in the B2B business, not B2C business. Anybody have idea what is B2B, B2C? So B2B business is the one where one business is taking help from another business to work better. Somebody has written, okay, business to customer. Okay. So let's say Amazon is working with another local supplier, like he want to set up a warehouse next to your house. In that case, you don't know who is the warehouse owner or the renter, facility renter. That's a B2B business. B2C business is you are consuming biz to customer. Blockchain and Web3. So this combo will work more into B2B business where heavy secured transaction has to happen, maybe between bank and an IT company, bank, another bank, bank and government. There you will see more of a blockchain and Web3. Web3 was too much in talk of town from 2021 to 2023. More towards what kind of internet wonders we can do. Web technology is not, Web3 is not towards faster speed. Web3 is more towards including blockchain into your digital world. Can I say that Web 2.5, if it is required, is a digital transformation of India? Yes. Like payment gateway, the way it is now seamlessly happening in India, no other country has. You can say it's a Web 2.5. Why? Because you have no physical token currency bill is being used for doing any kind of transaction. Think of that angle. So not only money, many things will happen using that. You will probably, people will stop buying gold completely. It will be only digital gold or whatever. So all that would be possible only when Web3 comes. Obviously, it is decentralized. Transparency will be more. Why decentralized? Any guess? Like in blockchain, you keep the products multiple places. Like that, it will happen. Advanced software engineering. This, at least you should give very focused one here. It is to be in next 5 years. And those who are in the final semester of any course, MCA, BCA, engineering, MTech, they have to understand software engineering is not dead, even people say you. But one thing you might find it difficult is if you want to do coding, everywhere microservices is there in picture, everywhere API is there in picture. And you find very frustrating that I have to learn coding, I have to learn design pattern, I have to learn advanced design pattern like microservices. Well, I give you one idea here. Try this. I do heavy trainings with students also. I mean, in future, if required, you can contact me. Microservice directly you can learn on top of coding language. In future, you will see that all the coding utilities, application development interchanges, ADIs, uh, whatever you are using will directly be able to write the code in the microservices. Microservices is like writing as per a feature, a small piece of code. If you understand package and coding languages, you will understand microservices. If you are not able to understand, I'll give you an example from recipe making. Today, if you want to make a burger, you buy a bun, you buy a tikki, you sandwiches together, you serve it as a burger. Well, in future might happen if you want half of the burger to be served. You might have sliced half bun, half tikki and all that. That's what is the thing, the feature-based coding, where based on what you need, a particular set of application will kick in. Right now, what happens in application development, if you're processing some data from database, lot of application codes still get kicked in, and that take a lot of memory and energy, battery, power, time, everything. To reduce that, we want to make smaller application sets and club them together. That helps into making API. I had a small discussion with a team of IBM on those who give support to Watson. So support of IBM Watson is in India. I think I can tell that it's in public domain. It's in Cochin. There, they had asked me that what will be the role of API in AI. I gave you one assignment to check back. In last 1 month, there was a talk of time in AI where they simply have made the AI engine accessible like an API. So find out what was the thing. What was the thing called? So technically now, if you want to consume, process some AI thing in your device, you don't need to manually call it and take the data and then use it. You can directly, like an API call, you can consume the API of AI. And it is immediately happening. It's not that tomorrow will happen. Those who are in the final semester of whatever study, please have 2 months of a kind of workshop around this. Proper way that will help you. Microservices first, API first. And by the way, those who are already working on API would probably second me that this was the expectation from the API, that you use the consume the API, forget about how it works, what it does. And that is now actually happening with the combination of microservices, API, and using API in AI. And that's immediate big thing. How do you use it? Let's say tomorrow, like today, you want to see something. Let's say, for example, Netflix or any other OTT devices. So today, either you are using OTT A, OTT B, or OTT C. Your API can consume them together and filter based on your mode. Okay, this TV serial is what you are trying to look for, is available here. And you pay only for that one. 10 paise, 20 paise, and all that. So it requires a lot of microservicing, API consumption, and AI on the API. So that's how I was talking about. Obviously, it will reduce your code very heavily. By the way, when we say low code, it's not that your developed code will be low. When I say low code, in a present, if you want to go through understanding a particular function happening in one coding, small set of code will be actually triggered from beginning till end. Lot of code will be there in the application, but small part only will be triggered for a particular work to be done. That's what called low. Anyone having idea of BCI? I'll just give 1 minute to think. What is BCI in human-centric computing? I'll just wait for somebody to write if. You would have seen a lot of movies where someone's brain is not working, right? No. Thank you, but you tried well, Lakshmi. Business to customer. Okay, that was okay. It's a brain-computer interface. Yes. Thank you, Sudhir, again. So think about a person who is not able to process his brain properly. So there it was that somebody made a device and it used to work. Now it is ulta, it's a reverse. You are trying to create a brain of a computer. If this really happens 100%, which is not possible, even to half of it, you will have a literally producing robot out of robot. Dangerous, but at the same time useful if it is limited. So basically, you'll be able to clone machine to machine where a brain is there. So BCI is going to be the brain of computer. Right now, computer is working as a helping us to judge something, but in future it becomes brain of a computer. I have enough to speak on this, but that will be more of a fantasy discussion than something else. But Is that a physical device it will create or not? No, no, no. It's like again an algorithm which you can use inside your robotics or inside your IoT devices to take the decision faster. By the way, how it happens, how it will be used to you, if you are able to tell BCI is what, how you will use that things. Again, API of AI. You'll be consuming it remotely. Then there is a talk of a discussion that in that way you can replace one brain to another brain. Will human will like to have BCI brain and all that? It's very early to decide on those things. It's not a time. Has it any impact on our career immediately? No, but 30 years back when the AI was being taught to colleges, student had the same question. Is it of our relevance knowing AI? Well, it was then not, but those who are into the premium designations, they do agree that they should have known AI at least 10% of what has been taught today to still have more sustainability. So I'll say after 10, 15 years, this is going to be a bigger boom. Right now, not, but maybe in 10, 15 years, it will be a bigger boom where you'll be probably literally remotely creating a brain for your computer, not for human, for the computer. Here comes onward. So basics I have done. From now on, it's more towards your, one second. What are the opportunities I have? Now I'm pausing again for 2 minutes. If the questions comes more, I'll increase more time. I want to hear from you what you want to know, what not. It's open for my chat discussion. If somebody wants to speak, then you write it. I'll ask the host to enable that person. Anybody can speak. It's not that only 1 or 2%. This kind of discussions should be more of communicative, no? Nobody is speaking at all. Was it a mandatory to join? No problem. It happens with me also many a time. So no questions till now, which means that this presentation is going boring. Okay. No questions, sir. Anybody else have any questions from anywhere? I heard that this is across India, people have joined. Is that the whole India is in the celebration mode of something? Like Friday evening? What roles does machine learning and AI play in future extraction and classification of brain signal in BCI? Oh, ma'am. Okay, I'll give you some hint, ma'am. So this is a question from Srirekha, ma'am. When it comes to the role, I am the right person to answer you. Let's say the two-way the role will be there. One role is to improvise your robots or your machines. Other side is just reverse, where you try to alter the human brain with the help of brain signals and all. So right now the neuron signals of brain is being read heavily. And as we know, the signals are in the part of healing process of human. MIT does, I don't want to brand someone, but is looking towards that right now, the biggest thing. That can the signals which gives a lot of our hormonal secretions, like that, if we could taper it better with the help of AI and healing process faster. Of course, cancer will be one of that. Or if not that, to try to find out what kind of the brain signal helps us in health. So that's the one thing is immediately we are expecting some traction in that. But if you ask me, if the BCI succeeds, we will be jumping to 50 years from here immediately. Lot of things will not do anymore, like lot of processing, learning. People will start asking, can we taper ourselves? So what I'm trying to say, using brain signal to alter brain That's the one thing is a debatable. But using brain signal in terms of warlike situations for robots and fighter bots is already there, ma'am. And it is being done. A lot of Indian companies are working towards that. Lot of processing, lot of future work is required in that. But as you have said there, the biggest problem is classifying it further because brain has a enough set of classifications required. So yes, in future you will see. Any other thing? Any other questions? Thank you for asking, Sri Rekha ma'am. Any other person? Anybody else? No? I'll still wait for 2 more minutes before I go for next. Okay. Okay. How many of you want some surprise at the end? Anyone? Any good surprises anyone want? Okay. Somebody have started transcription on. I don't think it's required anyway. Okay. One good surprise will happen is if you want to reach back to me in future, I'm not advertising here. I have been requested. Good surprise always welcome. If you want to reach back to me, you can seek my details and reach out to me. Every Friday, I anyway do some or the other network-based question answer sessions. If I'm unable to reach out, those meetings you can join and ask me directly. And in the future, I would be doing extensive 3 days hackathon on how you prepare yourself in the world of AI. If anybody would be required, you can reach out to me. That's a hackathon, award-winning hackathon. All right. Let me come back here. What this convergence map talks about. What if I blend the technologies and try to create a new set of jobs? That's it. It's a self-explanatory. See, then I'll explain a bit that how you can try to find your job in future. If you mix AI, IoT and edge, doesn't mean you need to do everything of AI. Some piece of AI, some piece of IoT, some piece of edge computing. If you mix, you will be able to make a lot of career opportunities. What is the future is, don't try to know everything of AI. Little bit of AI you know. Mix with any one chip level learning using IoT. Start your journey of your life. Because even for your continent, or precisely for our country, India is the immediate thing required. Jobs are not going anywhere. It's been getting transformed. But yes, you have to be very vigilant. Otherwise, you will lose the new opportunity. Opportunities are very more in terms of people who are very young. I always say to people, do not get fooled by learning AI tools, AI tools. No, learn the AI, learn the basic thing called Python. I know a lot of those who have joined here might not be even knowing very good Python and thinking of AI, ML and all that. I'm still telling you are right. Knowing basics of Python, implementing it in an AI tools is sufficient. Know the things. It's not that you do everything. You need to know the basics of many things and depth of one thing. But demand of general knowledge has increased heavy. Either you know AI plus IoT, so one chain of career will come. It will be very difficult to crisscross this AI IoT edge and jumping to cloud plus blockchain. So if you are good into cybersecurity, my humble suggestion is go towards blockchain. If you are good at cybersecurity, do not try to get into IoT. That's what I have tried hard lining here. If you are good into electronics, which one should be picked? Anyone can tell? Embedded or something if you are good at, which one should be picked? Anyone can tell? Somebody has written not one surprise, he wants 5 surprises. Okay. If anybody is good into electronics, quickly. For example, old story, Max Mobile, the founders, they were good at electronics, by the way, not into mobile and all. They were damn good in electronics. Okay. So if you are good into electronics, you have to choose the first option, AI, IoT. There you don't need to learn AI. You have to implement AI on your devices. If you are good into databases, neither 1 or 2, nor even 3. The fourth one, data lake, which is not here. So cloud and blockchain will go hand in hand. If you are very good into mathematical piece, you got an opportunity to work into bigger organizations, then that goes to next generation. I am not discouraging people who are not getting the opportunity. The nature and the God decides its own way, and you will be given enough opportunity in life. But if you wish to sustain yourself and if you have a zeal to learn quantum and all that, do not immediately jump into math of it. In next 2-3 years, slowly try to understand. You don't need to get a bigger certifications and all, because quantum is still going slow. It's not going fast. But yes, you need to learn a lot of quantum mechanics and all that. Not understandable to anyone 100%. A lot of hypothesis plays over role over there. But do not think to do AI anything you need to know quantum. Not at all. They are different. They are completely different. Real world examples, smart cities, healthcare and finance. I don't think you have any much to be discussed in this case. You can go ahead and do the quantum and AI for finance. You can, by the way, how many of you think that smart city project in India, how many smart cities are made by now? Can somebody give me the number? Anybody? You can answer me later after this on my phone number or wherever. Smart cities. Anyone have an idea how many smart cities? Right. Answer me later. One thing, if somebody is doing a course, BCom and then MCA, is there anybody like that here? Nobody? That's a good course, by the way, for future. BCom with MCA. All banks now want data analytics experts. Okay. So if you have anybody in future like that, you can think of, or if you have, by the way, the meaning was if you have exposure for finance background, it's good to have now. So the era of having only knowing technology is slowly going, not for the teachers. It will be still there. Students, those who want to get into business, you have to pick up one domain learning also parallelly. Maybe learn enough, there are 24 sectorial domains, pick up anyone and be an expert of it. Anyone can tell which one will have highest number of opportunity. I just need that. Number of opportunity highest, not the best opportunity. Number of opportunities. Which one will have higher? Can somebody text me? Okay. Surprisingly, AR and VR will have highest number of jobs in future. Highest. I'm repeating again. So please do research around that. When? Maybe next 5-6 years. all devices, almost all devices, which will be made into, okay, somebody wrote already. Very good. I did not see that it was written. So almost all who are into media, they will go for AR/VR. Facebook will be replaced by AR/VR. That's why they are working on that. Now, this is for faculties and others. If they really want to come out of, I know sometimes they get boredom that what we are doing. This is a very give thought-provoking from my side that if you get a chance, involve yourself in one domain, because earlier the way was to make a project being done. Now the time is to work together, multiple teams, and try to be part of a system development. So some of you might, a researcher might be working in ethics, some might be quantum, some might be blockchain. So the era is slowly glowing towards project to system development. So earlier it was a project development and project management and all. It's a system development, system management and all that. So bigger system. I don't think I need to explain the difference between project and a system. I just give emphasis for people who are trying to do research. I don't know right now how the AICT and all that works. Can different colleges come together for research work? I don't think it is still okay or tested. But if in future it happens, will be good that people from across industry start working to develop a system, because developing a system would be required engineers and non-engineers together. So if you see, AI cannot be developed standalone without a domain expertise. So that's one suggestion I have for any researchers or faculties. I don't want to discuss the case study. It will be too much for today, but I want to give you one thought-provoking thing, that if you think that TCS and Infosys are not doing anything into this world, there's a lot of talk down happens. I would suggest don't do that. Don't get into those discussions. Get into company team specific, that in Google, which team work into what kind of AI things, which Microsoft team works in what, does that India Microsoft works in that, does that, can somebody tell me which is the country who makes highest number of chip, your laptop chip, the atomic bombardment concept, which country does for chip development? Can somebody quickly write me? Anybody? It's a neighbor to China, Taiwan. It's not US. And recently they have requested to open their center into US. Taiwan is the #1 in chip. When I say chip, making the silicon farm and all. Anyway, that you need to check for the reason that they are going to be the game changer of, because that's the only country does it. Many other people are trying, but it's not happening. Okay. That's the future. Intelligence, decentralized, speed, and human-centric. When I say human-centric is try to solve more of a problem which involves human. When I say human, animal also you can include, I mean, other animals. It's a thank you slide. Not much, but don't go away. I'll probably give you one more way to connect with me. I always say, make use of tech, be wise, and make wealth. Yes, this is a real fact. If you are not making yourself wealthy, you will not be able to help your society. If you are not able to help your society, you'll not be able to help your nation. So always work on that. I'll quickly take half a minute. You can probably note down. Just a second. So this is my channel. If ever you are okay with, you can go to my official channel and I put a lot of people give small reels of videos. I give reels on AI. So I give a lot of reels of AI. I'm just putting it into chat with the permission. And if at all you want, you can note down. So this is my channel. If you want to search it, youtube.com/@Deepak Unoffice. If you write, you'll come to this. So these are my videos which I create for you all. And this is all free, not advertising, very sorry. It's not an advertisement because a lot of things you cannot reach out to me. So you can always go here. Whenever I have a free time, I create these things for you all. That's it from my side. I think it's always impossible to cover whatever was expected for, but I tried my best. Thank you, everyone. Over to the host. Let me know if anything else from the host perspective.
Yeah, any queries from the participants can be posted in the chat.
Your audio is very low. Hello?
Yes, sir.
Okay.
Asking any queries from the participants, they can post in the chat box.
Okay. I hope this was okay, posting my YouTube channel. I don't think that's a problem, no?
Yeah, no issue, sir. You can.
That's anyway for official purpose. All right.
Yes, Srivali, you can conclude the session.
Okay, sir. Thank you, sir, for spending your valuable time and sharing your knowledge with us. And a very special thanks to the good surprise as well. We will definitely utilize this wonderful opportunity. Thank you, sir.
Thanks a lot. I have given my number. People can always call me. I don't feel any problem. This is, if it is not used improperly, people can reach out to me. I don't mind. Or my YouTube channel is always available to people. Bless you all, those who are smaller to me, and bow and pray to all of my seniors. Being connected with teachers is always a great opportunity, and that too, what good had been on the Teachers' Day. I'm really thankful to you all for this opportunity given to me. I'm sorry for taking your evening, but that's how the world life is. We have to manage.
Thank you, sir.
Namaste. Thank you. Thank you. Thank you.
Thank you, sir. Now I would like to call upon A. Kavita Madam, Assistant Professor, Department of Computer Science, to introduce our guest to the participants.
A very good evening to all the esteemed faculty members, and on our behalf, we would like to wish you a very happy Teachers' Day, being in this noble profession. For now, let me take the privilege of introducing Mr. Bharat Kumar Reddy Gujavarti, who brings with him more than 29 years of rich expertise in software products, projects, and solutions for clients across the globe, spanning industries such as healthcare, education, agri-tech, life sciences, finance, and telecom. Over the years, Mr. Bharat Kumar has worn many hats as an entrepreneur, developer, designer, leader, manager, product architect, and head of technology organizations. His experience covers a wide range from leading very large scale enterprise solutions to architecting innovative small scale projects. His key strengths lie in product management, research and development, technology leadership, product strategy, and customer engagement. He also brings deep domain expertise in life sciences, telecom, and other sectors, having successfully designed and implemented solutions in critical areas such as clinical trials, volunteer data management, serialization, project management, risk analytics, quality management, and regulatory affairs management. Many of the world's top pharmaceutical companies count on his solutions, backed by high client satisfaction and trust. Currently, Mr. Bharat Kumar Reddy serves as the Chief Executive Officer at Pragmatic Systems and as Chief Technology Officer at Clin Alley and Learn Square Technologies. He is also the co-founder of Sunblue Technologies and Edify, and serves as a member of the Board of Studies in Computer Science at PB Siddhartha College of Arts and Science, Vijayawada. Earlier, he has held several leadership positions, including Senior Vice President Operations at Great Force Systems, Vice President at Goose Technologies, and Group Leader at Amdocs, where he played pivotal roles in driving technology transformation. Sir, we welcome you, and I now hand over the session to Mr. Bharat Kumar Reddy, sir. Thank you.
Yeah, thank you, ma'am. Hope you can hear, all of you can hear me and see me.
Yes, sir.
Okay. So, good evening, everyone, on this Teachers' Day. All of you are being teachers. I wanted to have a special thanks to all of you for serving the nation and bringing the next generation. And with that, I will start my presentation. Um, uh, Let me know once you all see my screen, please. Can you see my screen?
Yes, sir.
Okay. So I just wanted to, the today's topic that we will be talking about mostly on the programming for quantum computers. Um, and this, I think, ma'am, you already went through all these points as my introduction. With so many years of experience working on several programming languages, have been working from 91. I started my intermediate with computer science and then have been working on multiple languages, about 25 plus languages I have programmed, and still, even at these roles, I do hands-on programming for mobile and web application development and with latest Gen AI technologies. And quantum computing is something, even with this experience, um, which is like a shocker in the mind, which I wanted to talk to all of you, just pause here and talk to all of you that you had a couple of sessions on quantum computing. So I wanted to hear your thoughts or challenges or questions that you had from these sessions. Because today's session, I will not be going into the depth of quantum physics, quantum mechanics, or not even the details of how the qubits are managed and all. I'll be more focusing on what kind of problems we can solve as a company, as a researchers, and then what kind of things that we can do with various developments that are happening with quantum computing, and why do we need to even go there? Is there a reason, even with the LLMs that we have, the GPTs, and with all that, do we even have a need to go and do quantum programming? And is it for whom? Is it for the application developers like us who are working, or is it for the researchers who are working for the next generation products? So I'll be covering mostly those aspects. So before that, I just wanted to understand, maybe you can raise your hands, or I don't know, you can chat also. So what are the things that you understood from the two sessions you had on the quantum computing? anyone. I mean, see, I would like my sessions to be more interactive, please, so that we can have a knowledge share on. It's not just the presentation that I present. Um, so it will be better if we have some questions or some thoughts on the learnings that you had on the quantum computing. Otherwise, I'll start with the slide on the challenges. So what is the current challenge that we are having? I mean, today, why not? Why do we need to have quantum computing? Today we have classical computers computing for several years now, not just now. But if you have seen the evolution of computers from, let's say, 1980s or 90s, um, our systems or our servers or our the computing power has tremendously increased. I mean, the kind of computers that we had in 80s and 90s, and today my mobile phone has 16 GB of RAM and 256 or 512 GB of hard disk space or storage space. When we started working on 8088 or 8086, many of you might know, um, there is no hard disk. It's just floppy disks that we had, right? So it's just 25 to 30 years. The evolution has been so much that most of these capabilities that the classical computers have by reducing the transistors. So there was a theory, right, that every year the capability of transistors, the capability of computers is doubling, and it became saturated now. So it almost hit a stage where the transistor scaling is coming to a flat. So there is no more reduction of these transistor sizes into a microchip that can even is capable, because the size of the transistor is coming to the size of the atoms, and this is how today's computers have already hit that limits. So besides that, the transistor scaling is one part that is causing a challenge. The parallelization opportunities with the computer. So the kind of parallelization that we will do, we'll need to do, or we have the capability to do, is also becoming flat because of the kind of computing power it needs and the kind of challenges that it have when there are billions and billions of activities happening at a short span. And the third important challenge or the aspect that why quantum computing is coming into picture now is the energy consumption. So I keep talking about these LLMs, and then recently even Sam Altman, I think in one of the press conferences, he mentioned that please stop using please and these kind of words when you are prompting ChatGPTs, because every word takes certain amount of power and certain amount of water to cool the servers. And this is enormous. And then if there are some millions of messages that are being given to these LLMs, and let's say million please words, think about how many kind of tokens and how much of energy, how much of water and resource requirements that it consumes. So they are even now talking to people and say, don't, this is a machine, don't even, you don't need to please it or you don't need to do all this. So that is the kind of challenges that we are having with the classical computers as of now. But is it at the end of the day, is it stopping us doing certain things? No. And I mean, are we stopping doing developing all this? No. But we have to look for alternatives, and we have to also start thinking about a lot of things, how we can at least minimize some of these things, at the same time keeping our expectations very, very high, because we are now talking about artificial general intelligence like humans, and we are talking about scaling lots and lots of things, the computer generated programs, or even the co-pilots that can automatically do the end-to-end programming, right? So lots of things we are talking about. So we are not stopping on the expectations that we have. from these computing systems. At the same time, we hit almost the roof with these challenges. So this is the need that we are talking about. So the growth or even the kind of compute requirements, the kind of training that we are doing these models, petaflops of data is being trained per day to these through these models, and then it's not stopping. And then if you see, it is all 2019 kind of visualization that we have here, and it's growing almost at a rapid pace. The kind of uh, computations, the kind of data that GPT-5 that is recently released has, or the Gemini 2.5 has. So there is lots and lots of requirement or the need for the compute to continue to grow. And where is the chance? Where is the scope? And that's the major challenge that we are facing today. And what is the solution? At least, I mean, quantum computing is not new, and then you all have seen the history of quantum computing. It started way, way back. But with the advancements that we had in the quantum physics, with the advancements we had from companies like IBM, companies like um, other companies which are working very closely, D-Wave and others, the quantum computers have now reached a stage where we can start using them for at least certain activities and certain things. Let's say, what is the advantage or what is their unique parallelism capability? And we will also see what this means. These things can do tasks such as factoring numbers, simulating systems, optimizing algorithms. So all with an unparalleled efficiency, and they can do it in minutes or hours or days. For the normal computers, it takes million years. For example, the RSA encryption. I mean, when we talk about quantum computing and the kind of things it can do, think about if there is algorithms that are created that can break the RSA algorithm, the encryptions, and then bring back our passwords that we think are very, very um, safe in terms of 2048 public key encryption is done and nobody can track it. But all the banking systems, all the financial systems. So what will happen now if those kind of systems can be broken with few years of or few days of quantum computing power? Okay, we can still say that okay, quantum computers have not reached maybe till to the marketing level or to the level where we can do this, but it is very close. We have to be very, very careful. And then I think Shor's algorithm, which talks about breaking the RSA, is not new or is not today's. It's I think 90s still. And other advantage that we have with the quantum computing is the enormous scalability. And that's what we were talking about. How can we scale the things that we need from the perspective of computing power, from the perspective of utilization, and from the perspective of solving problems. I mean, there are several problems, there are several areas that we need huge power. And one specific area being working in healthcare, life sciences, pharma for the last 15 years. What I can say the personalized medicine concept is very, very relevant in today's market. And it is shocking that lots of medicines that we use in India are not even tested on Indian population because of the lack of clinical trial population. So can we have medicines or the pharmaceutical products created based on the Indian DNA or based on the DNA sequencing that was done on the Asian population? So those are the kind of computations that definitely quantum computing can help solving. Within few years, we can get into something called a personalized medicine. There will be when we get a fever, it's not paracetamol always. It may be paracetamol works for some people. Paracetamol will not work for all of them, all of us. and a lot of medicines work based on something called a placebo effect. So we can talk more on the healthcare, but what I mean to say here is that the kind of computing power that is required to create a medicine today, it takes anywhere between 10 to 15 years and billions of dollars spent by pharma companies to create one new medicine. Even for any of these, I mean, if you need to create one new medicine, anywhere between 10 to 15 years of research, with out of 250 projects that were taken up, one project succeeds, rest of 249 fail. That is the kind of industry statistics we live today in healthcare. So we need systems, we need scalable power, we need computing power that is enormous, and that can scale very, very fast, and that can give us results, allowing us to achieve things that that will help the next generations, that will help in a lot of areas that we'll speak in the next slides. So, I mean, if you look at this slide, we are talking about a small computer that we had. The size of computers today is 10 qubits are required to have the entire capability of that Commodore 64 kind of a system. And AWS M4 instance is equivalent to a 1 million Commodores. And you see 1 million Commodore systems created, one classic AWS M4 instance. But how many qubits are required to replicate that? Just from 10 to 30. So that is the kind of enormous or the scalability that we have with quantum qubits. And the entire global cloud, 1 billion kind of M4 instances can be mapped or can be um, um, scaled with 60 qubits. And this is the kind of capability that we are talking about, even though there are lots of things that are still under evolution, that are still under um, error-related things we talk about. But still, the capability is there, that from 30 to 60 qubits, we can entirely cover the global cloud. And how this enormous scalability is coming? This scalability is coming from the concept of superpositioning, which is the property that enables these quantum bits, the qubits, to stay in multiple states at once, multiple states, and 2 power n states simultaneously if you're talking about n qubits. And it is exploiting the vast landscape of possibilities in parallel. So this is not related to the parallelism concept that we talk in the classic computing, like threads and those things, because those are one kind of parallelism, again limited by the kind of um, binary operations or the binary digits that we have in the classic computing, right? So here it is 2 power n states simultaneously and exploiting the possibilities, and just with 300 qubits, I mean, we're talking about 60 qubits here, but if we are talking about 300 qubit quantum computing, in theory, it can represent greater number of states, and 2 power 300 can represent greater number of states that are there, the particles in the observable universe. I mean, think about the kind of parallelism that can happen. I mean, when we get into a stage where the quantum computers can take into the real problem solving or real world problem solvings in the mainstream problem solvings. So that is what we are talking about, the kind of capability again. So what are the areas? I mean, is the quantum computing for everyday problem solving? Is it for the kind of Instagram, social networks? Is it for um, and currently it is, there are certain areas that benefits very, very well, mainly because of few things. One, the error rate and the tolerance for the error, the kind of environment a quantum computer needs, and also the cost that is involved. But still, considering the cost that we spend and considering the obstacles that we have, without having a quantum computing. So in some areas, definitely it is an advantage. And there are areas that we are talking about machine learning. So machine learning models, we have been talking about AI, ML, different machine learning models for several years now. But last 20 years, if we talk about, it has grown to a level where we have hit almost now with the kind of LLMs, we are talking about new training sets that need to be done for LLMs. And we are also talking about SLMs now. Most of the LLMs are being moved to a small language models where we need more capability and more processing of things at an individual level. So development of new training sets, new algorithms. So machine learning can take advantage of the quantum capabilities. Classification and sampling of large data sets. Again, it's definitely a large computing power and large operational capabilities can be taken as an advantage here. And the second line is more relevant to the real world problems like supply chain optimization. So we will see one example in the coming slides about the supply chain optimization, forecasting and optimizing for future inventory, for future demand. So the companies that are talking about generating, let's say, agriculture, and we can also forecast and see are we meeting the inventory demands. So these algorithms will help there. And there is scheduling problems, logistic problems that can also be solved. Ma'am, is there a question? Okay. So supply chain related scheduling, logistics, they can also have lots and lots of challenges. And I have one example for that to be shown. And next, the robotic manufacturing. So we are talking about too much of robotic activities. I mean, even with LLMs, I have been talking to one researcher in Singapore last few weeks back, and they were talking about now challenges like um, uh, parking robots. I mean, the automatic parking of the robots. So they have so many robots now, and then they are writing algorithms to even find a place and make a robot park when the work is done. So there are so much of robots that are coming in. We have been seeing that in movies, but now it's becoming reality, right? So that one is for reducing manufacturing time and cost, and then all other problems related to manufacturing. Then computational material science. We're talking about better catalysts for batteries. We're talking about algorithms for calculating electronic structures, solar related, all other areas where the material science related algorithms, pharma life sciences. There are lots of things that I mean is not even mentioned here. Alternative energy research. Can we have a different kind of energy that is created by replacing these particles, atoms, and those kind of things, right? So there are many more advantage areas that the research is going on, and as a quantum computer programmers, we can, and if we are interested in writing algorithms, so this is the area where we can start thinking about writing a unique algorithms, patentable algorithms. I think one of the things that is growing very, very fast is the number of patents that are being applied for these quantum algorithms. And being in the research, being in the I mean academic, I think a lot of research comes from all of you into creating new and new algorithms that can solve real life problems using the quantum computers. And these are growing at a rapid scale. We are, I mean, we are not even able to visualize how fast or how rapid they're scaling up. And this is one simple page that actually tells us how rapidly they are going. I mean, in 1927, the quantum theory was invented, but then it took about 55 years even to talk about a quantum computer, 1982. But even that is 50 years ago, almost, right? So after that, there 18 years is almost nothing. But look at the rapid and exponential growth that is being happening from 2000 onwards, last 25 years. There is a 7 qubit class Alamos that was created, but now we are talking about 1152 qubits by D wave, 2048 by D wave, and many other qubits. And when we refer back to our previous slides, 300 qubits is what is needed to even map the entire atoms or particles or states in the entire universe. So where are we? I mean, we are almost there in creating the capability or creating the hardware part of it. Now it is up to the development teams to even talk about, or the developers or the programmers to start creating algorithms that make use of these capabilities and this power. And that's what is happening today. And this map is from 2016 to 2033, and this is only IBM's. I have not taken all other things, but if you talk about the kind of research that is being done at IBM, and I think this will be shared with all of you, so I will not go in detail about each and every part of this slide, but the major focus is on talk about 2000 qubits by 2033, and the error corrections is reduced drastically, and that is what IBM is focusing. And it's not just IBM working on this today. There is D-Wave. There are lots of other companies who are working on different kinds of technologies, different kinds of quantum computing systems, not just one methodology or one technology. So this all looks good, all is fine, but how does it relate to, let's say, programming concepts that we learned, the programmers that are there today, and the kind of subjects that we are teaching to the programmers, right? So I just wanted to bring all of us back to the traditional computing concepts. We all know that the binary digit is either 0 or 1. It's a switch, and it's just a flip of a coin that we can say. And when we learned about in our first classes, I mean, you might have these subjects are being taught in the early stage of computing people. We're talking about ASCII, so it's like 128-bit a mapping of these characters, and then we are talking about UTF-8, which is again 2 power 32 kind of characters, and mapping all different language characters, and then emojis and all kinds of characters in a keyboard. So these technologies are, again, all of them are related to the number of bits that are required to handle data or to manage data that much. And then, okay, now there are bits, there are data, there are registers available, there is zeros and ones that are there. Now the next level is we learned about gates, logical gates, and or not, then XOR, NAND, NOR. So multiple types of gates which created circuits. So we have also talked about these circuits. And then these are the early days of computing where, especially, I mean, when we learned about microprocessors, when we had a paper on, so we had to draw 8086 or 8088 and then talk about all these kind of gates. There are adders, half adders, full adders that need to do, and also assembly language that we use to even manipulate those data in those registers, and the machine instructions as well. This is all in 90s. But is it relevant today? I mean, to learn for a programmers that are coming into the traditional market today, do they know all this? Are they doing all this in detail, in depth? I don't think so. I mean, most of the, you see, the computer, maybe they learn this paper as a computer scientist or a computer engineer or a person who is doing a master's in computer science. However, today the computer programming has gone so much to that level that programmers are not worrying about how the resistors are working, how many transistors, what kind of gates that are viewing, what circuits, what algorithms. So there is one set of teams that are taken care of, but the majority of the people moved into application programming. So if you look at, ask me now, as a programmer, last 30 years, maybe I learned these concepts. I use it, applying maybe in terms of logic, but we are not writing programs at this level. So we have moved far ahead. I mean, 90s, 40s, 50s, maybe till 70s, we were writing the assembly language code. But then once the mainstream languages, the evolution happened, then we started writing instructions in English. So we started more and more. And now today it's more of like a co-pilot that is taking care of all this, right? So, but this is the classic computing where it is today. I mean, it started way back 75 years, and then machine and assembly languages were used. But in quantum computing, we are starting now, we are at that stage now where we are writing the instructions to manage qubits, instructions to manage the quantum hardware, and then also to write algorithms that can solve problems using the capabilities at the lowest machine level. I mean, that is where the core capability should be required for a quantum computer programmer. This is very different from the application programmers that we will see now. And so these terminologies actually confuse me a lot. That's why I asked this question on have you had any questions on the previous two sessions that you had? In a traditional computing model, we are talking about data that is stored in something called bits that we already know and many times, right? And it's a switch or it's a flip of a coin or any of those, either zeros or ones. Now it's a new switch that we are imagining where the switch can be on and off at the same time. I don't know how. I think it's a three-dimensional aspect that is being told to us like this, that on and off at the same time. And this is the core idea of the qubits. Finally, the result, when we actually measure a qubit, the result will be either 0 or 1. But while, I mean, from the start, while it is doing the processing till it stops, it can have a spinning coin. I mean, the coin that is revolving around, when it is spinning, it's not definite whether it's heads or tails. So it's in a state of being both, from which angle that you are looking at in a 3 dimension. And it's only when you stop it by observing or measuring it, you actually finally know whether it's a 0 or a 1. How it is important, what it is important. So when we are talking about multiple computations, so even in the classical model, if it is not a bit, I mean, if you're talking about a hexadecimal number or an octal number, we can represent lots of data than we are doing it with the binary numbers. Here it is multifold, it's exponential. So that what both on and off, we are calling it as superimposition. This is one of the key principles, two key principles of quantum computing for a layman to understand. And the second principle is entanglement. So that means that if you have two bits or two things or two coins and you have linked them, they are saying that it is linked somehow. That somehow is through the passing of the energy or whatever the activity, the passing of ions that happens, and they are now entangled. So when they are connected, wherever they are, if you stop one, it lands on heads, then the other one will lands on tail. So wherever they are, when they say wherever they are, I mean the kind of examples that are being given, like one, let's say one coin is in Earth, and the other coin went to Mars somehow through whatever the kind of teleportation or the transportation, the methodologies that come. So you can control immediately what is happening there in the Mars, the coin there with the coin that we have on Earth. For an example, it looks to me as a sci-fi movie, but however, I mean, this is coming to reality. I mean, this is not just the theory, or it's not just the movies that is there. So this is how the qubits are linked, and they can influence the outcomes of each and every qubit that is there. So now refreshing the concepts of classic computing now to the quantum computing, the bit there is now qubit. The superpositioning allows the computers to evaluate many states at once, and it's not like threads in the parallelism. You can evaluate, so you can create a quantum state where all the possible combinations can be given to that particular quantum qubits, and then you can measure what happens to that all at once. I mean, that is the major advantage, and that's how we can achieve that kind of um, uh, response back within that short period of time, right? And the entangled bits are correlated regardless of the distance, and measuring one immediately determines the other one. So there is always a possibility of, uh, let's say, data communication. So you want to understand whether what values went, what values did not go. So those kind of things, and then managing things that are from the remote. Teleportation, for example, we have seen some videos recently that they achieved some level of teleportation, which is through the quantum bits, like recreating. But like I mean, the real quantum teleportation is not exactly same as in the movies, that the person is here and the person is also there in the other time zone. It's like it is destroyed at one place and then put it into other place because of certain um, controls that are there. Quantum states cannot be cloned due to a non-cloning theorem that quantum computing or quantum physics follows. So that is one. And then the measurement actually collapses the qubits, which is one of the major, I can say, disadvantage. As of now, the moment it's not like um, debugging a program and looking at what a variable is currently when we are running a program and seeing it. If you attempt to do that, you are actually stopping the program. So what we have to do, we have to define the state, let it run and complete the state, and then use the results or use the trends that are created from that to determine what is happening with these algorithms. And the other relevance from the gates that we have heard, there is Hadamard gate, there is poly X, poly Y, poly Z gates, there is CNOT gate, there are phase shift gates. Again, there are gates. So the qubits again will be created into a circuits using these gates, and then circuits are created which will be used for executing the algorithms. And gates are reversible, like the XOR and all we have in the traditional programming. And quantum control is limited. Like I said, loops exist, but you cannot arbitrarily read, modify the qubits in the mid of a computation. It's all, if it is in a state of execution, it has to complete that state. And they cannot be cloned due to the non-cloning theorem. And then you can run these circuits multiple times to gather the distribution of the results, how they are coming up. And then based on that, your algorithm's result will be decided. So these are all the basic quantum concepts that I related my to the knowledge that we have as a traditional programmers. Now, what is programming for the quantum computers? What does it mean? So there are multiple programming languages that are there, that are available for the quantum computers. These programming languages have been designed to run on the quantum computers, obviously, and are very, very different from the classical computing program. Why? Because these programs have to understand, like I said, these are at the level of assembly languages, or these are at those levels right now. So these languages and the people who work with them at this point of time have to have a very sound knowledge of quantum mechanics and the principles of quantum mechanics and the underlying mathematics. Very, very sound knowledge, because otherwise, I will show one example. The way Microsoft has put the pricing of a quantum computer on their website, it itself also requires a lot of thinking to even understand how much it costs for me to run a quantum computer. I'll show that example at the end. So, and other important thing, the quantum computers, they work on the practical use cases. So it's not just I'm writing a hello world program or I'm writing certain things, right? So it has to work on a practical use case, which it is not very easy to get those use cases. And those kind of use cases, if it can be done in a classic computer, why do we need even a quantum computer to do it, right? So we have to have algorithms or the problems and the use cases that are not solvable until now. I mean, intractable until now for humanity, and superseding all the work done by the classic computers. And this is the major differentiator between the programming languages that we talk about for quantum computers and the traditional classic programming languages. So is there a small understandable difference here? Yes, the difference comes down to the fundamental elements. A classic programming system is programmed by us as humans who utilize the linear binary elements, which are zeros and ones, which are then processed into information. And we all know, I mean, actually, the people who understand the zeros and ones, the binary numbers, the ASCIIs and all, we can even read the memory and understand what is happening, or what we can try to get information back. But in quantum systems, however, the properties of the particles, I mean, it's all they are fed into multi-dimensional matrices. So multi-dimensional matrices, so that the basic unit of quantum information that can determine the results. It's not just we can read the bits and then understand and do something, right? So that is the primary difference. And it's not just starting, and it started several years ago, like we have seen in the evolution. So quantum computing programming languages, this is taken in 2018, and there are multiple things that came after that. But if you look at the kind of hierarchy that it has, the bottom is the quantum device. The quantum devices can be of different types. Each vendor is doing, like IBM, Rigetti, D-Wave, Xanadu, Google, Microsoft, Kilimanjaro. So multiple vendors doing multiple things, and different hardware is being developed with different proprietary technologies. And it's not that all of them will have the same quantum technology. So it is very, very difficult now. It's not just the Intel chip that we are writing programs or a 32-bit register. So the manipulation of those quantum aspects might be different for each of these vendors also. So that is another complexity when we talk about quantum computing programming. right? So the hardware needs certain machine assembly language to manipulate the hardware. That whatever the algorithms that are given to the circuits, and then circuits data needs to be converted into qubits, which need to be passed on to the hardware to manipulate the quantum state of those machines. So assembly languages are required. OpenQASM is the assembly language that IBM uses. Quill is what Rigetti uses. QMASM is D-Wave uses. So there are multiple machine instruction languages that are being used at the assembly language layer level. And now, so there are qubits, and then there are circuits, and IBM has something called Qiskit, QIS kit, which has several components that covers the entire stack of things that are required to be a full stack or a full level quantum programming. So Qiskit Terra is a circuit management layer which can manipulate or create do the activities on quantum circuits. Rigetti uses a library called PyQuil, which is based, again, we have a Python library for it. And then QBsolve is used by D-Wave. Circ is the Google's libraries. We talk about that. And Microsoft is talking about Q Sharp. It's a language that Microsoft created to do these activities. And Quibo is by Kilimanjaro. Now, there are circuits, there are qubits, hardware is there. Now, there are algorithms, which in the classical thing also, we have algorithms, right? Algorithms to add two numbers, algorithm to find a prime number. So there are multiple algorithms. We started with small things, and then now today our day-to-day programming itself is divided into multiple hundreds of algorithms, thousands, millions actually. So there are libraries, languages that are used to write these algorithms. Aqua, Qiskit as part of the IBM. Groove is Rigetti's, and QSage, TOQ, and then the strawberry fields. There are open fermion. So multiple things that are there to write algorithms. As a quantum programmer, quantum computing programmer, understanding these many things again is another dimension of challenge. One dimension we talked about is being very, very knowledgeable about the quantum physics, the mathematics, the underlying theorems. And second is the deep knowledge of the use cases that need to be solved. And now the third dimension is these kind of programming languages. So if you are talking about the research community, the students, the faculty, I think the kind of activities that you will be doing is developing these algorithms, either for one or multiple sets of these quantum computers. It can be an IBM computer or AWS, or there can be there are libraries that can work on multiple machines, the multiple quantum computers. So there are full stack libraries. Qiskit is IBM again, and then Forest is Rigetti. Circ is Google. Microsoft has Microsoft Quantum Development Kit. And there are again Project Q and universal languages, which I talked about. When I say universal languages, these can talk to multiple quantum devices. They can manipulate, they can do activities on those. So this just gives a framework of kind of things that are already available in the market. And this is 2018, by the way. We are 7 years ahead of the time this information is available on the screen, right? So there are lots of things that are happening, and there are multiple components like we discussed. It's not just the programming language itself. We are talking about the quantum instruction sets. So the assembly languages are also called as the quantum instruction sets. These are used to turn the complex algorithms into physical instructions that can be performed on quantum processors. So it takes the algorithms from here and then transform them through circuits to the hardware, right? So these are quantum instruction sets, CQuasm, Quill, OpenQuasm, Blackbird. These are all the examples of quantum instruction sets. So this is a sample code that I've taken for the Quill. From typically we can use PyQuil to do this library, and the Quill compiler can be used to execute it on a quantum processor or a simulator. So this reminds me actually of the assembly language or the machine language we used to write as for 8086, 88, 286 kind of a processors. So these level of languages, we are there at the same time. So if you look at these instructions, H is a R naught, the kind of thing, C naught we're talking about, and then measuring the value of this, and then there are certain loops, label, skip, label, and this is like a control structures that we used to write in the programs, right? So declaration of the variables. So this is the quantum instruction sets as an example. So same way we have components as quantum SDKs. The word SDK is very, very popular now. And the kind of SDKs that are already there now today for the quantum computing. So in the initial days, we don't have any SDKs until certain point of time in the traditional programming. But now, why do we need SDKs? I will come back to it a little bit. But quantum SDKs are available, and then they actually give us a lot of flexibility and um, uh, accessibility to those programs, algorithms, and then prepare them to run on the cloud-based devices. So we now have cloud-based quantum computers available as well. Or there are simulators. So, I mean, when we are talking about millions of transactions or those many things, I think running it on a real quantum computer can be very, very expensive. And we might need to do multiple iterations, multiple things that we need to do to even achieve or to even see that our algorithm is even able to do what we are trying to achieve. So there are simulators that are created, which again, classical programming models never had simulators. Now let's say, the mobile app development environments have simulators, iOS simulator, Android simulator to run applications. But a quantum simulator is a simulator that can actually mimic the quantum computer and can perform those processes and then try to give us whether the program works or not. And there are lots of SDKs available now. Again, it's not one. There are multiple SDKs available from different vendors. And this is just a list of some of them. And so when we talk about the programming languages, again, there are imperative, there are functional programming languages. And if you look at this list here, QCL, quantum pseudocode, QHash, QSharp, QSI, Q language. There are many languages that are there, and I mean, some of them really I don't even remember or never heard of also sometimes. The list is growing at almost at a rapid pace. So, okay, there are so many languages, there are so many things, there are so many activities, but let's even talk about only a handful of things that we need to focus on as a quantum programmer. And surprisingly, the first thing that came up in this list is Python. And Python actually is a classical traditional computer programming language. It's not even a quantum language. But most of these programming languages, the libraries, the assemblies, they have actually created SDKs that are for Python. We can use them in Python. So there is a QuizKit library IBM has created a comprehensive library that can be used in Python. So with quantum computers, we can even manipulate circuits, create algorithms, and then it supports the quantum hardware and simulators also. Circ also has an open source framework for writing and manipulating, which is again Google's quantum processors and simulators, and Python has it. And PennyLane is another library that we can even run it in Python and manipulate. And why Python is so popular and why Python people are using Python? Because it has lots and lots of SDKs already, not just for the quantum circuits or on the classical computers. It is kind of a hybrid thing that we can even have jointly. I mean, we can have a classical program plus a quantum program coexist. And why do we need that? I'll come to that. And the algorithm development is very easy in Python, and then people are very fascinated about Python. And we have seen today most of the developers, most of the computer science engineers coming into market know Python, and they can very easily adopt to these writing algorithms or being a quantum programmers. So it is easy for them to shift, and it also integrates with data science tools, because the quantum computing, we are talking about manipulation of data, manipulation of lots and lots of possibilities, parameters, working on the mathematical concepts and all, and the scientific concepts. So Python already has lots and lots of support for it. It has a strong presence in data science and machine learning. We don't need to tell that again. And quantum computing needs it. So if I work on certain data, I need to plot it, I need to look at it, I need to maybe do additional manipulations after the quantum processing has completed. So Python is a very good choice for it. And the biggest thing is the community and resources that Python has today, including resources, tutorials, documentation, forums. So it is very easy for newcomers to learn and engage with quantum, and that is the major advantage. So it is easy for all of us to shift towards quantum computing. It's not that we need to learn those 20, 30 new Q languages, or the languages that even we never heard of. They will have SDKs. We can start using our native Python language and then start working with quantum computing. That's the topmost transition path for a classical programmers to quantum programmers. And even in that list, if you keep Python aside, we have IBM's Qiskit, which was it's all, I think it's 2017 that IBM gave this as open source, and it works at all levels of the quantum activities, circuits, pulses, algorithms. And then IBM actually had this research, and then in 2017 they made it open source. And it can, if you look at, it can run on the quantum experience IBM devices or on simulators on a local computer. So it is that simple. And I just gave a link here. If you want to see, there are in 2022 there are about 63 quantum computer simulators available from major players, and this list is growing actually. So you can refer to this list later on. But that is how this is another library. Again, Qiskit also has a Python SDK, so we can use this part of the Python as well. And other one is Ocean. It's again a suite of Python tools. It's not independent. And D-Wave is another company which is doing lots and lots of research that we have seen. D-Wave already created 2048 qubit quantum computer, and also so D-Wave is a company that is promoting the Ocean as an SDK for talking to their computers, their quantum computers. And Q-Sharp is the Microsoft. It is in conjunction with the Quantum Development Kit of Microsoft, QDK. And again, it also came in 2017, that time frame, and it's a domain-specific programming language. So there is a little difference when we actually write programming language in Q Sharp and then in Qiskit and Python, other languages. So Microsoft always has a different way of doing things, and that is actually visible, the way these programming language is actually doing certain activities. I'll show one example of one problem, how it is done differently in Q Sharp and all. And the other quantum programming language that we can even talk about is Google's Quantum AI. And now it's in 2018, it launched the alpha. And it is becoming more and more popular, and has built-in simulators. It has, again, the entire framework that is given by Google. All this is fine, and I maybe we will know and learn quantum mechanics, quantum physics, mathematical concepts, and we have a use case, and we start writing programs in one of these languages. So, what is the major challenge that the quantum languages are having today? Is the hardware error rate in quantum computer. Just see the difference of the hardware error rate in a classical computer that we have today. It is, I don't know, almost negligible. Even there are examples where this 1% triggered certain phenomena in computing, that unexpected results came. But this is all negligible. We are using classical computers for several years now, for almost for the mission critical applications. And chance of hardware error in quantum computer is 0.1%. So it's most likely. So when we are talking about solving complex problems, the major challenge is this error rate, and that is why there are lots of Dilbert jokes on quantum computing. When you get time, you can even look at it. They say that he comes and asks one of these guys, "Are you working on quantum computer?" He says, "Yes." What is the state of it? He says, "At one point it is fully completed, my project, and at other point it did not start." And the manager asks, "Can I see it?" Then the moment he sees it, it collapsed. Because we are talking about, we cannot monitor or measure it. The moment we measure it, the result can be either ways. Okay. So that is how the quantum computing is today, and the error rate is 0.1%. So these are the things that will get solved in the coming years, and that is where the quantum computing will become more and more, I can say, utility-based product development or algorithm development in the coming years. Let's say maybe in 10, 15 years. So what do we do now? I mean, quantum computers have errors, and then the error rates are fine. But so that is why people work with something called hybrid languages. Hybrid programming languages help quantum computers reduce these errors by facilitating a tight integration between the classical and quantum computational resources. If I want to measure something, maybe the measurement happens in I don't know. I mean, the classical computing is the program is what is interacting with the end users, and the quantum bit of it or quantum piece of it is hidden from the traditional user manipulation, so that real-time control can be achieved and during the quantum computations, and then reduce the errors. And that is where the hybrid methodology of these programming languages are being adopted uh, today. So this is an example flow of how a hybrid model that works, like a Pikewill program that we have written, which goes to a controlled classical computer, which can to a pulse program, and then is sent to QPU, the quantum programming unit, that will be given to the qubit operations. and then which will process and spit out the bits, which will be sent back to the end user. So the QPU and this processing is not being touched by the end users, and they are interacting with this application. So that is how the hybrid models are working today. And then when we talk about what kind of problems that we can solve and what kind of algorithms that are already there. So this is one quantum approximate optimization algorithm which is called QAOA, which is an algorithm that is already there in Qiskit and other libraries. So it can solve traveling salesperson problems, scheduling problems, k-means clustering problems, Boltzmann machine training problems. So there are lots of things that these algorithm constraint satisfaction problems can be solved using this particular algorithm that is there. So this is a sample code written in PyQuil using the Forest. If you remember, Forest is a full stack library of Rigetti. So this is like a 20 line, a 19 line program that can actually do the QAOA algorithm. So it is that simple, but I don't understand a single line of it, what exactly it is doing. But today, I think the traditional programmers are also becoming like this, like when they are interacting with LLMs and when they're interacting with libraries that are already available, NumPy, scikits, and all. We are writing programs like this. We are utilizing the algorithms and functions that are already available in those libraries. We are not going in depth into those algorithms, what is written and all. So we can start the quantum computing, our journey into quantum programming in this way, like by start understanding certain basic concepts of what it is doing, and then being a hybrid programming, if you look at it, there are variables, there are uh, manipulations that are being done on the variables, and then there is results that are being displayed. So we can start very easily using Python and with these SDKs that are available. And that is how we can start our journey. And where all it is going, I mean, with all these quantum, with all these LLMs, there are lots of, I can say GPT-5, Geminis, and other things. There is something now coming up which is called quantum artificial intelligence. So now bring artificial intelligence concepts and quantum computing together, and then process much more, process at a speed, at a level where traditional classic computers were not able to do. Which one big use case that whole world is talking about is AGI, artificial general intelligence, which is like a human-like intelligence for a machine. Which is scary, but that is where we are going towards. And again, this is all what is happening in this area. Obviously, the top companies are already into it. Google has a TensorFlow Quantum, TFQ. It's an open source library for quantum machine learning. I mean, they already have this open source, and they have been working on this library for um, artificial quantum systems. To look at those kind of things that are coming up. This is all to give an idea of where the quantum computing is already, while the rest of the world is just talking about quantum programming, quantum computing, the basic concepts and those things. What it all means for a normal developer. I mean, I am always coming back. My mind always asks the question, okay, there are so many things that are happening, and there are so many other things that are happening. We don't know until the LLMs hit the market. We don't even know that those kind of things are happening. Even though there are beta versions of GPT-1, GPT 1.5, 2, even though they are all there in the market, people who are testing, very few people know about those until GPT-3 hit market and whole world started using it, right? So now the quantum computing is at the stage where maybe it's GPT-1 or maybe even before, 0 point some version. For a normal developers like us, what does it mean? I mean, why, how do I need, or why do I need to use quantum computing? Where do I need to use? Definitely, we talked about algorithms or problems where the traditional computers are not able to solve. One such problem, I mean, for one such problem is integer factorization. Where is it used? Integer factorization is used in the RSA encryption. That's the most secure encryption that we are thinking that is being there. And RSA encryption actually uses 2048 bits, and that is the size of the RSA key. And the number of possible factors to get it is so huge that we think that the traditional computers will take billions of years to break it. That is why that encryption is so secure. But there is a quantum solution for it. Shor's algorithm is developed in 90s, and that can break an RSA algorithm, RSA encryption very easily within few days or maybe within few hours. That's the kind of problems that the traditional computing programmers need to look at definitely. So there is one small statement. I mean, now with the Shor's algorithm introduction, till that point of time, like 2000 or 1980s, 90s, quantum computing was just a theory. We have seen so much of gap in the development even when the quantum computing was identified and then the first quantum qubit program. But the moment the Shor's algorithm came out and they were able to say that, okay, we can break these kind of RSA encryption, it became a national security, it seems, for countries like America. They said that the quantum computing has to grow very, very fast, and they started funding these all the initiatives. And that's why you have seen so much of growth, exponential growth in the development from that point of time. So one algorithm actually fast tracked lots of things, and this is algorithm is very close to the classical computing activities that we do today around the world. And then other example that I am trying to understand where it will help. Let's say we are talking about companies like FedEx, Amazon, or maybe a food delivery or Flipkart or something like that, right? So you have, let's talk about 100 delivery trucks are there. And then each truck needs to go to 20 points every day, which is a simple activity that today even our local Amazon trucks are doing. So the job is now to figure out the efficient routes for all these trucks to visit all the locations, minimizing the time, fuel consumption, and distance. Okay, it might be a problem that we might have solved with the classic computers. No. No. Why? Because for just one truck with 20 stalls, we were talking about the possible unique routes of 20 factor, which is like 2 quintillion possible routes for single truck. And we are talking about 100 trucks there. And we are also talking about the complexities of the real world. There are variables like traffic, which can change in time, right? Sometimes one way of traffic is more, and sometimes the other way the traffic is more. Time windows. Some customers want their packages to come at specific time intervals. Truck capacities. A truck can hold so many packages. You can't just send, the route is optimal, you can't send everything in one truck. And the weather, I mean, obviously there are lots of conditions, when weather conditions, shutdowns, those kind of things. So it is impossible in a classical computer situation to have an optimized solution for this. So what we are doing, we are trying to have a real-time, near real-time kind of a more optimal solution based on the algorithms that the classic computers support. But the real algorithm can come when we implement a quantum computer with a parallel search, we can have optimization across all these parameters, and we can achieve this, which can save lots and lots of things for the companies, for the environment, and many other things. It's not just the profits for the company, it's a lot of other things also, the carbon emissions, the sustainability, and lots of other things. Right? So, other important example that I thought we should discuss is the portfolio optimization. So we have, let's say, I have a portfolio of 10 stocks, N stocks, and then I want each stock to return, let's say, 10%, 12%, 15%, whatever. And then the goal is obviously to maximize the returns and minimize the risk, and that is what the mutual funds are doing today. So the traditional finance models are using quadratic optimization, which is called QO kind of problems, but that's not enough. I mean, there are lots and lots of things that can be done with quantum computers, which can solve QO using QAOA. We have seen that algorithm in the previous screens also, quantum approximate optimization. So like this, there are hundreds of algorithms that are already there, created by people, and there are algorithm libraries that are available open source in the internet. And I have listed down some of those libraries. TensorFlow is Google's library, and then we have Amazon Bracket algorithm library, Qiskit circuit library, the OpenFermion we talked about. OpenFermion is Microsoft, Qualtran, Libvox. So there are many libraries that are available, quantum algorithm libraries, which we can look at and explore those libraries and work on quantum programming. We have about 10 minutes. I just wanted to take you through few of the links. I think this slides will be shared with you. So there are lots of resources on the internet that you can explore. You can start very easily how to write programs. When we looked at Project Q is in the list that we have seen, Project Q is on the top, right? It is a universal language. It's a universal language. So you can go and look at the Project Q resources in this. The link is given here. And there are a lot of things, lot of libraries, and then you can run your programs on IBM Quantum, AWS devices, Azure, Ionic, and many other devices actually. And then there is another library that we can say this is one of the largest algorithm library that is there on the internet. That's how they promote. And this is Classic, is a high-level quantum modeling language. And I will show a few things there also, and the link is given. You can explore that. Qiskit algorithms, there is a GitHub library, and then we can even go to IBM site and create. And this is a GitHub library is not being supported by IBM now, but the algorithms are there. There are lots of algorithms there. And for even for academic purposes and even for the programming purposes, Qtip Quantum Toolbox is there, which is again a Python libraries that we can talk about. IBM is giving a 30-day free trial for their quantum platform. We can create an instance of a quantum computer there, and we can run our workloads. We can run our small programs in the real quantum computer than the simulators as well. Circ again is given an open source platform. We can go there and run our quantum program. So this is how the Circ, we just import it, and then we create a qubit and then create a circuit with this is a phase X kind of a transformation, and we can also simulate using the Circ simulator and then print the results. We can do that. And a couple of things I wanted to show, if time permits, but I wanted to just pause here and ask if there are any questions. and then we can go to quick things. Maybe let me complete this and then go to questions. So this is our account for the IBM this thing. I can create an instance if you look at it. So if you look at, there is a 10 minutes of free time per month on the selected IBM QPs. I mean, that is how expensive these quantum computers are today. 10 minutes of time they're giving uh, on the QP. What we can do with 10 minutes, I don't know. And this is how the computing was in 70s and 80s. People used to book the computer time and then run their programs. That's where we have got all the dry runs, algorithms, flowcharts all came up. So this is the state where we are with the quantum programming now. And $1.6 per second if you need to pay for it. So think about uh, how much we need to spend to actually write an algorithm, but the returns are that much, and the program specific time up to 8 hours. 20 years back, I heard that the computer times are limited by this, and now we are seeing with quantum computers. So there are many other. So yeah. So there are many other things. The classic I showed, there is an editor here, the classic editor with all the algorithms loaded. You can have different algorithms, code, the quantum functions loaded here. There is a classic library of algorithms. So this is the largest collection of quantum algorithms and applications across the globe. And the Qiskit, we can even run a program, and then I have created a sample. So this is the quantum sample that actually creates it creates a circuit and then it runs and gives a result. So I can just run this program very easily like this, and it can give me counts. I can get with 3 qubits, 111, 500 times, and 00, 500 times. And then if I run it again, the number might vary also. So it is a probabilistic number. So now it is 503 and 497. And the expectation values is 4. So uh, we can start our basic journey into the quantum programming through this. And there are the project queue that I talked about. You can have Python quantum programs. Circ, actually Google has, when I go to Circ, the environment is this. You can write a program here and then run it. So it said you just run your program and then these are the things that you can do. So you can even have quantum virtual machine from Google and then start working on it. These Qiskit algorithms, there are lots of algorithms, documentation here, and IBM Quant I spoke about. And the last thing that I wanted to share or show here is this. So just look at this pricing plan for assumed quantum providers. IBM has given straightforward per second $1 and all. This is how Microsoft is telling that the charges. So they will charge so much $100, and then this is the formula into this, into this. I really don't understand how they charge and how much they charge. Okay, so that's about it from my side. Taking you through the programming aspects of it. Anything, any questions, anything, I'm open to take. So what programming models or interfaces does Classic use to create quantum circuits? I think there are multiple things that are there. Classic is again at a level where it's universal. I think it can work on multiple things. Um, uh, I mean, there is a free link available. There you can explore those algorithms that are there. When they're talking about the largest library, I'm assuming that they have all the kind of things. I have checked some of them, AOA and others. I mean, they're available as part of that. So it allows circuits, it allows all the things also. Any other questions? Any other points, aspects that you need to understand, ask? Thank you for patiently listening. I mean, it's 9 o'clock, and then thanks everyone once again. If there are no questions, that's it from my side.
Thank you, sir. So let me extend my vote of thanks. It's my privilege to extend our heartfelt gratitude to our esteemed resource person, Mr. Bharat Kumar Gujavarti, CEO Pragmatics Hyderabad, for delivering such a thought-provoking session on programming on quantum computing and the clear explanation of transition from classical computation architectures due to challenges faced to this paradigm that is quantum-based computing. You also gave the roadmap, and we truly appreciate the depth of knowledge and practical perspective which you shared, sir, on enormous scalability, superposition, programming languages, instruction sets, components of quantum computing, quantum AI, real world use cases. And this will definitely contribute to our professional growth, sir, and it will leave a significant impact on us, on the participants. And we are grateful to you, sir, for the time and effort you have dedicated to this FDP and participants for joining and making this session meaningful. Thank you, sir. Thank you for giving this opportunity. Over to Samrat, sir.
Yeah, that was a very wonderful session, Bharat sir. Thank you very much.
Yeah, thank you so much.
Yeah. So participants are requested to fill the feedback form, and those whoever have filled can leave the session. Thank you, Bharat sir.
Thank you. Thank you. So, anything else for me, or I can leave?
Yes, sir. You can leave, sir. We'll take over the session.
Okay. Okay. Thanks again, everyone. Have a good night and a good weekend.
Tomorrow the schedule will be, I mean, like there will be 3 sessions. One is from 2 p.m. to 3:30, and the other one is 3:30 to 5 o'clock, and the third one is from 5 to 6:30. After 6:30, we'll be having a validatory function, and the assessment will be starting like around 7:30 to 8. For attempting the assessment, you need to log into your Atal portal, and there you will be having a link called assessment at the left side of your menu, and there you can click the link and you can take on the assessment. The assessment will be lasting for 1 hour, which consists of 50 MCQs, which are formulated using all the presentations which were given by the resource persons throughout these 6 days. And the questions will be in a moderate level so that everyone will be able to answer them. And you need to get a minimum of 70% of score in the assessment to be eligible for the certificate. And tomorrow we'll be showing a live session on how you can take the assessment. That's not a problem. So participants, stay tuned for tomorrow's sessions also. Thank you. Yeah, those whoever have filled the feedback form can leave the session.